Chapter 2 is really, it's not about, we're spending one day on quadratics. Chapter 2 is really over polynomials. So instead of having a chapter over parabolas and then a chapter over the other things, we have just one chapter over polynomials. So that's why we start off with a general definition of polynomials. I'm not going to expect you to come back up with this yourself, but I want you to see this. This is what the general definition of a polynomial looks like. Oops, I messed that up. That should be... Here, let's just get rid of that. There's your general form of a polynomial. What? The dot, dot, dot? Yeah, that's dot, dot, dot. The dot, dot, dot just means it continues. We don't know how many terms there are in here because this is for any integer n. Well, not for any integer n, any whole number n, sorry. A 0. So that's the general definition for a polynomial. The only reason I want you to see it is because I want you to get used to the idea of using n as a subscript and a power. Because as you get in higher math, you see that more and more often. In fact, whenever you get into upper math, you don't use x, y, and z as variables. In higher math, like if we were doing three-dimensional math, these would be our variables. So that's kind of often left field, but I want you to get used to seeing stuff as subscripts is the reason why I'm doing it, because in higher math, sometimes you're dealing with more dimensions than you have letters. So sometimes you have a variable that looks like this. So again, that was kind of getting way beyond the point of what we were doing. All right, now, your book gets really screwy with their terminology. Their terminology is like against all the other terminology I've ever seen. Sorry, I'm just moving that. So I'm changing their terminology. So just realize this, when you see instructions in your book, their terminology is not the same we're using in our notes. Because whenever they're talking about this equation I'm giving you for standard form, they don't even give it a name, which I don't even know why they do it. So in every book I've ever seen, what we consider to be standard form for a polynomial is this. Again, your book does not call that standard form. It doesn't even give it a name. But this follows along with the definition of a polynomial. Now, if we go to well, here let's do a little bit of definition here. This is called, and this is for all polynomials. I just figured it'd be easier to define it down here. This is called the leading coefficient. So leading coefficient is just the number in front of your highest power. With quadratics, it's the x squared. The c is considered your constant term. It's constant because that term never changes because it doesn't have any x values with it. So it doesn't matter what you plug in for x, this is always going to be that value of c. Trying to think if we need anything else for today is whenever I'm talking about stuff, but I think that's about it. Okay. As far as graphing, this one is a little bit tedious as far as graphing goes. I'm going to kind of give you the rules here, and then we'll go and we'll graph it. To start with, whenever we graph, we start by finding your axis of symmetry. Negative b over 2a gives you the middle of your parabola. Now, where that comes from, if you've never seen it, that's supposed to be 4. Sorry. Getting ahead of myself. That's your quadratic formula, right? This plus or minus takes you to either side of the middle. So if you get rid of that square root, there's your middle, which is where we get that negative b over 2a. That negative b over 2a gives you your axis of symmetry. Now your vertex always has to occur in the middle of the graph. So the x value of your vertex has to be that negative b over 2a. Because wherever that vertex is, it has to be on the axis of symmetry. Now, to get the y value of our vertex, what we do is we take our function and we plug in the x value. And that will give us the y value for our vertex. Okay, so after that, we plot another point. You can either plug in another x value and plot another point, or you can use the a value. The a value here works exactly like the a value worked before. Doesn't matter. You can choose however you want to do it. Basically, you need another point. Then we use the symmetry. For our third point. Okay, so making it really difficult and writing it out without any numbers, that's how you do it. So that's one of my goals as we go through this, is to be able to get you guys to explain stuff without numbers. Best way to help you guys be able to do it is for me to show you how to do it. But in math, what we want to do is we want to generalize concepts so that we can do them without numbers, because as soon as you put in a number, it ruins your concept, because then it makes it very specific for that one thing. If you can do it without numbers, then it makes it so that you can do it for everything. That's where whenever towards the beginning I was talking about tricks. Tricks don't work all the time, because whenever they do tricks only work whenever they put in those specific numbers. In order to prove a trick works all the time, you have to be able to do it without numbers in it. All right, so I have a couple examples, and then we'll move on to the next thing. All right, so to do this one, I'm going to go a little bit faster. All right, so we find our axis of symmetry. So I take negative b, b is 4, divided by 2 times a is 1. So my axis of symmetry occurs at negative 2. So that means the x value of my vertex is negative 2. To find the y value, I just need to take and plug in negative 2. So let's see, that's 4 minus 8, which would be negative 4, plus 3, which would be negative 1. Oh, minus 3. Okay, sorry, so that's negative 7. So 1, 2, 3, 4, 5, 6, 7. Okay, now you can either plug in another point or you can use your a value. Just to make it quicker, I'm just going to use my a value. So my a value is 1. That means I can go over 1, up 1. Use my symmetry. Since I'm 1 over from my line of symmetry, I go over 1 to get my other point. Whenever you graph these, I'm looking for 3 points. As long as you have 3 points, you're good. If you want to go farther, that's up to you, but I'm just mainly looking for 3 points and a curve. You okay with that? You want to try the next one on your own real quick? Wow, I made that one really big, didn't I? All right, there you go. I put in a few points. I just want to make a point also. You guys have a y-intercept that's readily available with these. Your y-intercept is that number. Right? If you plug in 0, your y-intercept's that last number. Yeah, Taylor? It's 3. Because whenever I put that in and I get that 3, this would be your axis of symmetry. I just didn't draw it in. So if you're the type that likes to plug in points, go for it. Just be smart about it, you know. That point is really easy to get. The only time you can't use that point is whenever that point is your vertex. Okay, good with that part? Any questions before I rip it off and move on? Yeah. You can, yes. And that's what I'm saying. An easy point to use, you could use 0, because that will always make these cancel out. So you always get that last number. So you could use this point and this point. The only time that doesn't work is whenever b equals 0. Then you'd have to pick a different number to plug in. Okay. Now, this is where it's going to get confusing with the book. And I apologize for it. I cannot follow the book. I hate the book. All right, vertex form. And one of the reasons I don't want to follow the book is because this is what you were taught was vertex form in Algebra 2 and in Algebra 1. Vertex form is this one. It's called vertex form because you can easily pull your vertex out of it. Your vertex is just your H and your K. Your book does not call that vertex form. Your book calls that standard form. Yeah. So, I am sorry, but your book is going to talk about standard form in your instructions. Anytime it mentions standard form, we're talking about vertex form. So that I'm sorry for that, but again, in all good conscience, I cannot call that standard form because that does not make sense. And again, that would totally go against everything you guys have been taught before. Okay, graphing, we're not going to spend a whole lot of time on graphing because you've already been taught how to graph that. Again, H and K is your vertex. So I just go find H and K on my graph. And you can do one of two things. If you like plotting another point, you can plot another point, or you can use your A value to find your next point. And then again, you can use that symmetry to get your point on the other side. But we already did that in chapter 1, so I'm going to do one quick review, and then we're going to move on because we've already covered how to graph those. Sorry. All right. So with this one, what would my vertex be? Negative 2, 1. Remember, whenever you pull a number out of the parentheses, you always use opposite because that minus sign was in the formula. So since that's a positive 2, we have to use a negative 2. So my vertex is at negative 2, oops, wrong way, negative 2, 1. Then my A value is negative 1, which means I would go over 1, down 1. I only get to use that once, though. So I use my symmetry to get my other point, and there's my parabola. Now again, if you would prefer to plug in another point, I am totally okay with that. It is not as easy as with standard form. You don't get to use your y-intercept because this is not your y-intercept. So if you want to plug in 0, you'd have to actually plug in 0 and figure out what it equals. Let's see, that would be negative 4 plus 1, negative 3. I'm a little off on this side, but again, if you want to plug in a point, that's fine. I have no problems with that. All right, you good with that graphing? Any questions? Okay. There is another form that you guys talked about in Algebra 2. There's intercept form. We're not going to worry about that. So those are the only two forms we are concerned with. Okay, we have, I think, 4 more problems. So hang in there. All right, finding vertex form from standard form. This was the point of completing the square. Completing the square yesterday was the easy version. This is the harder version. Problem with this is you don't have it equal to 0, so you can't make numbers disappear like what we did yesterday. Now you have a couple options. I'm going to just do it one way because I don't want to cause confusion. If you've done it a different way before, you can continue doing it that way. What I'm going to do is I'm going to move this number to the other side. The other way of doing it is to keep all your numbers on one side. I think doing it this way will cause less confusion. Okay, so what I want to do is I want to create vertex form. Difference between vertex form and standard form is that square. In order to create that square, I have to complete the square. So exactly like what we did yesterday. So what number would I need to add on here? 16. So just as a review from yesterday, what I need to do is I split that 8 into half. So that'd be 4 and 4. So then to get the number I add on here, I need to multiply those two numbers together. So 4 times 4 would give me 16. Since this is an equation, if I add 16 there, I also have to add 16 over here. Okay, so on this side I have y plus 11 equals, okay, go ahead and factor that. Yesterday at this point we were solving, so we square rooted both sides. We don't want to do that today. Today we're creating an equation, so what we do today is we move that 11 back over to the other side. Now you may be thinking, oh, he lied, that's not that much harder than yesterday. Well, that was the easy problem. Okay, good with that? So we took standard form and we changed it into vertex form. And we did it using completing the square like we did yesterday. We followed pretty much the same steps. We moved the 5. We completed the square. And then instead of solving like we did yesterday, we just moved the 11 back over. All right. Now, I'm going to continue to try to do it that way. Because again, I think that way makes it easier on people.